So in this video, we'll talk about the so-called Rayleigh distribution. So by definition, a random variable y is said to have a Rayleigh distribution if it has the following relationship between two random variables x1 and x2. So if this relationship x1 squared plus x2 squared square root is equal to y, then we say that y is a Rayleigh random variable and they both have the same variance. So this is important here. So x1 and x2 has the same variance, and then the Rayleigh random variable has a scale parameter which is also equal to sigma. Okay. Okay. Now what we have to prove is we have to prove that the Rayleigh random variable has this distribution. Okay. And y is always greater than or equal to 0, and this you can easily check from the relationship here that y is x1 squared plus x2 squared, so it's always positive, okay, or non-negative. Okay, so now let's start. So now how do we find the PDF? We'll use the CDF method, so which means that we will say f y of y, this is equal to probability of y less than y, which is equal to probability of root x1 squared plus x2 squared is less than y, which is equal to the integral f of x1 x2 dx1 dx2 such that x1 squared plus x2 squared is less than y. Okay. Now here we have to also say that x1 x2 they are independent. Okay. So now if they are independent, this guy is what? Is the product of the marginals. Correct? Okay. So now let's start with this. Let's say this is my I. This is my I. So then this I is what? I'll say again x1 squared plus x2 squared is less than y. So then I will say f of x1 f of x2 dx1 dx2, so which is equal to, so 1 over root 2 pi sigma squared, 1 over root 2 pi sigma squared, so 1 because of x1 and 1 because of x2. Then we have e to the minus x1 squared over 2 sigma squared minus not minus, I will say times e to the minus x2 squared over 2 sigma squared dx1 dx2. Okay. Now to save space, what I will do is I will say here 1 over 2 pi sigma squared, and then this guy I will erase, and this guy I will write it as the power of minus x1 squared minus x2 squared over 2 sigma squared, and I will say dx1 dx2, and again my condition is that x1 squared plus x2 squared is less than or equal to y. Okay. Now I can also say minus of plus here. Right? I can take minus outside and I can say plus inside. Right? Okay. So then what we are going to do is we are going to say use a transformation of variables. What I'm going to say is I will say x1 this is equal to r cos theta, and x2 this is equal to r sin theta. Okay, so this means that x1 squared plus x2 squared this is equal to r squared, or square root is equal to r, and tan inverse of x2 squared over not x2 squared, x2 over x1, this is equal to theta. Okay. Now since we are using the transformation of variables for two variables here, we have to use the Jacobian here. So Jacobian is what? J, this is equal to partial x1 over partial r, partial x1 over partial theta, partial x2 over partial r, partial x2 over partial theta, which is equal to, what is this guy? This guy is cos theta. What is this guy? This guy with respect to theta, this is minus r sine theta. This guy is sine theta, and this guy is r cosine theta, and this is equal to r cos squared theta plus r sine squared theta, which is equal to r. Okay, so then we know that this r theta, this is equal to r times f of x1 x2, where x1 x2 they are equal to whatever the function was. So let's say this mapping is known as A, right? So then x1 x2 is r written in terms of r theta using A. So I know it will be clear in a minute what it means. Okay. So now our integral becomes what? So our integral is, what was this? Our condition was root x1 squared plus x2 squared is less than y. So I'll say r is less than y by sigma squared e to the minus r squared over 2 sigma squared, and then the Jacobian, and then dr, and then dt. So this is my I now. This is my integral now. Okay. Now I can say r is always positive, right? So what I can do is I can remove this thing. I will say r is equal to 0 to y and theta is equal to 0 to 2 pi. Okay. Now this guy is what? This guy is easy to handle because we have r squared here and r here. Okay. If I just do the change in variables, I just say u is equal to minus r squared over 2 sigma squared, then du, this is equal to minus 2r over 2 sigma squared dr, which means that r dr, this is equal to minus sigma squared du. Okay, and the limits of r are 0 to y, so the limits of u will be 0 to minus y squared over 2 sigma squared. Okay, so now using this transformation, what do I get? So theta is still there, theta is doing nothing right now. So u is equal to 0 to minus y squared over 2 sigma squared 1 over 2 pi sigma squared e to the u, and then r dr is what? Minus sigma squared du, correct? And then dt. Okay, so then this guy goes with this guy, so I'm left with 0 to 2 pi minus 1 over 2 pi eu du, 0 to minus y squared over 2 sigma squared. Okay, so then this gives what? The integral of eu is just eu, so I can say 0 to 2 pi minus 1 over 2 pi e to the minus y squared over 2 sigma squared minus 1, because e to the 0 is 1, and then d theta. Now do we see any theta here? We don't see any theta here. So this means all we have to do is we have to multiply it by the difference of this and this. So then this I will get minus 1 e to the minus y squared over 2 squared minus 1, which is equal to 1 minus e to the minus squared over 2 sigma squared. Okay. So this is my CDF. Okay. And I think I wrote here. So this should be not the PDF but the CDF. Okay. So this is the CDF here. So what will be the PDF? The PDF is just the, so f of y, this is equal to d over dy of f of y, which is equal to what? We just integrate this guy. So we have minus of e to the minus y squared over 2 sigma squared times minus 2y over 2 sigma squared. Okay, so this minus and this minus goes away, this guy goes away, and what I'm left with is y over sigma squared e to the minus y squared over 2 sigma squared. So this guy is the PDF and this guy is the CDF. Okay, so this was about deriving the PDF and CDF of the Rayleigh distribution. The trick here is just one. The trick here is that you have to use the transformation, this so to speak, trigonometric transformation. Okay, and use the standard Jacobian method to convert x1 x2 into r and theta, and then the integration becomes straightforward. So hope it was easy to understand, and thanks for watching. Hope you liked it.